On May 14, 2026, the marketing paradigm of humanoid robotics officially collapsed, replaced by the metrics of industrial endurance. Figure AI initiated a continuous live broadcast on the platform X, demonstrating their third-generation humanoid, Figure 03, operating inside a live logistics environment. By the 24-hour mark, a fleet of these machines, running on the proprietary Helix 02 Vision Language Action Framework, had processed over 30,000 packages. The data from this test provides the first unedited baseline for autonomous physical labor. The baseline numbers reveal that Figure 03 achieved a cycle time of approximately 3 seconds per package. This performance directly matches the average speed of an experienced human warehouse worker. However, examining the footage without illusion reveals the immediate engineering boundaries of current hardware. While the physical manipulation of objects is fluid, the machine exhibits systemic processing latency. Before lifting a non-standard item, the machine frequently pauses for 2 to 3 seconds. This is the world model inference gap, the exact moment the onboard neural network calculates the geometry, center of gravity, and optimal friction requirements of an unfamiliar object. Furthermore, the physical reality of a 24-kilogram bipedal machine limits its runtime to approximately 3 to 4 hours under heavy load. To bypass this thermodynamic and chemical constraint, the industry is moving away from perfecting individual units and shifting toward fleet orchestration. During the May test, Figure demonstrated what they term an autonomous failover strategy. When a unit detects a critical drop in battery voltage or a mechanical degradation in its joint actuators, it does not stop the assembly line. The robot autonomously signals the central dispatch system, requests a replacement unit from the reserve pool, and navigates itself to a diagnostic dock. The backup robot assumes the position within seconds, maintaining continuous operations without human intervention. Looking past the immediate spectacle, the true direction of robotics over the next 5 years is dictated entirely by manufacturing economics and supply chain dynamics, not artificial general intelligence. Data from the first half of 2026 shows a massive divergence in the global hardware race. While the United States leads in foundational behavioral models, production scaling is heavily concentrated in Asian manufacturing hubs. Industrial reports show that platforms like Unitree and AGI-Bot have driven the capital cost of hardware down to $15,400 per unit. The immediate future of robotics will not feature general-purpose domestic assistance. The structural chaos of a human home requires too much real-time edge computing and carries too high a liability for accidents. Instead, the real roadmap is restricted to highly structured, predictable industrial environments. The immediate targets are automotive assembly lines, parcel sorting hubs, and dark warehouses, where lighting, floor conditions, and tasks can be mathematically standardized. The metric that matters for the rest of the decade is not how human-like a robot can speak, but the mean time between failures. Currently, the probability of a mechanical or software fault during an 8-hour shift remains close to 100%. The companies that win the next phase of the technology market will not be those with the most viral videos, but those that build the most robust self-maintenance infrastructure. The transition from software to heavy physical industry is officially underway, and its success will be measured strictly in cents per hour of uninterrupted operational uptime.